All right, here is another stoichiometry problem, and it's a little different than our last one. And the main difference is that we're no longer given moles. Now we are given grams to talk about with our conversion. So how many grams of NH3, how many grams of H2. Before we dive into this one, I want to look back at the tricycle one and see how it is different for that. So for the tricycle one, it would be saying, like, if I have 20 pounds of frames, how many pounds of tricycles can I make? So right now you might already have an idea how this is going to be different. If I use my old method of doing this, I said 1 makes 1. And so I would say, okay, if I have 20 pounds of frames, if I'm looking at a 1-to-1 ratio, then in theory, we would expect that to give me 20 pounds of tricycles. However, this just doesn't really make sense. If I have frames that weigh 20 pounds, I add a bunch of wheels to them all, make as many tricycles as I can, I'm not going to get 20 pounds of tricycles out. They're going to have to weigh more. So this sort of analysis, we cannot do this if we have a unit of weight, like pounds or grams for that matter. So we have to do something else. And if I have 20 pounds of frames, what we need to know is how many frames is that? And the only way we're going to figure that out is if we know how much a frame weighs. So somehow we'll have to look up this information, figure out what a frame weighs. Let's say that one frame has a weight of 5 pounds. So I'm going to say 1 frame equals 5 pounds of frame. This is something I've either measured or looked up, but it's there. So once I know that, I'll be able to figure out how many frames I have. And then I know, oh, every 1 frame makes 1 tricycle. So that conversion is still valid, but I just can't use that solely to do this problem. So 1 frame equals 1 tricycle. So I will need this conversion, just not yet. Now, once I figure out how many tricycles I make, well, that's most of the way there. I still need to figure out how many pounds of tricycles. So I'm going to need the information. Let's say a wheel weighs 1 pound. So I'm going to need to know what a tricycle weighs. And a tricycle, if a wheel weighs 1 pound, I get 5 pounds from the frame plus 1 pound per wheel. That's going to be 8 pounds of tricycle. So I have to add that up. So these are 3 exchange rates I'm going to need to solve this problem. And that's usually the most you'd ever need. So if I do this, I would say, okay, I have 20 pounds of frame. And I know that every 5 pounds of frame gives me 1 frame. So that's essentially 4 frames right now, but we'll hold off on that. I know that 1 frame makes me 1 tricycle. Again, I'm just using these things here. I've used the 5 pounds for 1 frame. I've used the 1-to-1. And then I know that 1 tricycle is 8 pounds. So I'm using this third conversion. So every one of these things I've written down, I've used the same way I would do fence posting, right? I have these things canceling, and I multiply it out. So 20 times 8 is 160 divided by 5. I get 32 pounds of frames, which should make sense. 20 pounds of frames, 32 pounds of tricycle. So the tricycles weigh more than the frames do. And again, that should make sense. But this is sort of how we go about it. Instead of just using 1 conversion, we had to use 3. So depending on the problem you have, you'll either have to use 1, 2, or 3 conversions. Let's go back to our chemistry problem. So our chemistry problem is similar in that we don't have moles here, we have grams. So I have grams of NH3. I have this nice equation I would like to use, 3 to 2. But if you remember, this 3 to 2 doesn't have anything to do with grams. That just tells you that 3 moles of H2 make 2 moles of N2, which is useful, but it's not immediately useful because I have grams of H2. So I first have to figure out what is the relationship between moles of H2, 1 mole of H2, and grams of H2. What is the mass of 1 mole of H2? And I'll get this information from the periodic table. So I'll consult the periodic table, I'll look up the mass of hydrogen, and I'm going to round this off to 1. Usually I like to keep 2 decimal places, but I'm going to kind of skip ahead here. So H weighs 1 gram. However, I don't just have H here, I have H2. So it's going to actually have a mass of 2 grams. So 1 mole of H2 has a mass of 2 grams. And the common mistake people make is they see this 3 and they want to use that for the molar mass. When you find out the mass of H2, you ignore coefficients out front. You ignore this 3 because you have already accounted for it here. We're not going to use it again. So 1 mole of H2 has a mass of 2 grams of H2. So that's going to let us figure out how many moles of hydrogen we have. Then we're going to go from moles of hydrogen to moles of nitrogen. But the question is asking me, actually I should say NH3. It's asking me how many grams of NH3 I'm going to end up making. So I also need to know, what does NH3's mass? 1 mole of NH3 equals how many grams of NH3? So I'm going to have to add up the mass of NH3. So I'm going to need to look at the periodic table. Turns out nitrogen has a mass of 14. There are 3 hydrogens, each weighing 1. So 3 plus 14 is 17. That's 17 grams of NH3. So I have 3 things here. I need to use all 3 of these, in this case, to get my answer. So fence posting, I'm going to again start. I've got 48 grams of H2. But that's no good. I need to get to moles. If you're doing a stoichiometry problem and you want to go from one chemical to another, you must get to moles. So 48 grams of H2, the relationship is 2 grams of H2 is equal to 1 mole of H2. So I'm going to say 2 grams of H2 is equivalent to 1 mole of H2. All right, so I've made use of this conversion here. All right, so now I'm in moles of H2. I only have one other that has moles of H2 in it, and that's right here. So that is 3 moles of H2 is equivalent to 2 moles of NH3. So now I have used my second conversion, and now I am in moles of NH3, but I am ultimately looking to get grams of NH3. So I use my last one, 1 mole of NH3, and 17 grams of NH3. Remember, I'm just fence posting problem. I'm making sure the units cancel. I had grams of H2 here, so I want grams of H2 there. Moles of H2 here, moles of H2 there. Moles of NH3 here, moles of NH3 there. So I multiply this all out, and then I will get my final answer. So 48 times 1 times 2 times 17. I'm going to divide that by, so that gives me 1632. On the bottom, I have 2 times 3 times 1 is 6. So I'm just going to do that. I get 272 grams of NH3. And that's my final answer for this stoichiometry problem. So it's a harder process. It can take as many as 3 steps. The first thing you want to do is write out all your exchange rates, your conversion factors, because that's going to help you map out what to do. If you had trouble figuring out this fence post, look back on fence posting and how to do that, because this is really just a type of conversion. It's sort of a somewhat advanced conversion, but at its core, stoichiometry is really just about converting units. So, until next time, I am Derek Genova. Have a delightful day.